they make it, and I'm going to put in parentheses success, or they miss it. You could say he or she, in this case was a he, but I love it. Failure. Hey, I'm going to add this too. Just in case me as someone was pondering this concept of these being independent events or independent trials, like maybe the first time they try to do it, made them better at putting that ball in the hoop. So we'll assume they're independent events. In these cases, we call them trials, so we assume these are independent trials. And we're set.
Don't you have to put this as a finite number of times? Because the book says fixed number of times.
I think it would be great if you wrote that, Art. And when
Yeah.
Art added something else, the book talks about how there's got to be a fixed number of, outcomes. Meaning, all right, 40 attempts. Like, you're not going to go on to infinity. But we don't have to mention that. But Art, I think it's great if you add that. It's the idea, there's got to be some fixed value. Like, how many times are you going to do this? I'm going to try it 100 times. Like with the airplane flights, when we get to that, well, how many flights are you talking about? Like 20 of them, 30 of them, 100 of them, the course of a year? Because then you're dealing with snow and what? All the other elements, true? All right, so that's fixed numbers, so Art, that'd be great if you mention that, but you don't have to. All right, so great job at that. Now this is new. To me, I still haven't asked the probability question. But I want you to, this is what the author says, compute the mean. Now, if you have an idea of what this is, raise your hand. I haven't done this yet. There's a formula for this. I haven't written it on the board. I just have a feeling that many in this room will have an idea what this is. So the mean is like the expected amount of baskets that are going to be made, right? They're getting 40 attempts. This person's pretty good. He makes 80% of them. We're like, what would be the mean? You go, mean? What would be the mean of this binomial experiment? What do you mean by that? What would be expected? Does anybody know?
32.
32. How did you get that?
Multiply 40
You
times.
took the 80%, multiplied 40. Who else knew that? That was outstanding. People had a sense of this. I didn't even put a formula on the board, but it is very simple. So now I'm going to add it over here. You go, what is the mean of a binomial experiment? Now, do you remember the symbol for mean? It's like a
mu.
A mu. So I'm going to put this. Mu for a binomial probability distribution is, again, multiplied. That would be the mean. So in this case, n times p, this was a 40, this was a 0.8, and 40 times 0.8 is
32.
32. Sometimes you get a decimal here, like 32.5. What I mean by a decimal, it's not 32.0. Your calculator. All right, that's the means. So,
Standard deviation.
here you go.
Is that not a division thing? That's just showing?
Yeah,
Oh, okay.
because you just asked that, Mia, that's a great question. I'm going to erase this in case someone else in this class thought I'm dividing it.
Okay.
I wanted to show to get this value when we multiplied what? N times P. But the way I present it up here, you might go, you got 32 divided, what is going on here? So I'm just going to leave this. And I'll move this over and go, hey, we took the N value, we multiplied P. And when we did that, this N was a 40. This P value was a 0.8. And we got a result of 32. Now we're going to interpret this. Bless you. We're going to interpret this. We're just going to explain it in our own words. I know, welcome to stats. We get to use these cool functions. But we talk about this stuff. All right. What does this 32 mean? Will this work? We expect this person to make 32 baskets out of 40 attempts on average. Does that sound good? That's what we mean by this mean. It doesn't mean they're going to make it, right? So hey, on your test, watch this. This is what gets marked wrong. Interpret the mean, and someone goes, he's gonna make 32 baskets. And we don't, is that true?
No.
How can you predict that, right? You don't know that for sure. It's very likely though. Now if you put that word in, that's good. So interpret the mean, I'll say, do you like the word expect? We expect him to make 32 out of 40 baskets, and then we can add on average. We expect him to make 32 out of 40 baskets, or 40 attempts, on average. We're just emphasizing that's really what's going to happen in terms of the mean, what's expected. Cool. All right, here comes a question. Now, if you want, you get to use anything on those calculators. D. What is the probability that he makes exactly 35 out of 40 baskets? All right, what's the probability he makes? Now, I'm going to capitalize this word. Exactly. That's a buzzword. That's a key word. Exactly. Liz, we were talking about wording before. We got to look for key words. All right, what is the probability he makes exactly 35 out of 40 attempts? I'll put 35 baskets because he's trying to put it in a hoop. Let me just say out of 40. Question mark. Is there a cool button we can use? Which one can we use?
Oh, so this is 35 is x, right?
You bet. Now look at this question. Binomial experiment. 40 trials. Probability of success is 80%. In this question, we now have a x value, the number of successes, the way this is being asked. What's the probability? There are 35 out of 40. So hey, what's a cool button on that calculator you could use? Now you can do that. That'll be fine. Some students prefer this, by the way. They go, I don't like that, I like to just do this. I'm like, fine. But is there a cool button?
PDF, binomial PDF.
Binomial, go to the distribution. Be careful, don't use normal. Use the binomial one. There's a normal one on that list. That's coming up later in the course after spring break. Use the binomial one, okay. And I'm going to put this on the board here. Binom PDF, just in this upper corner, we put an N, and we put the P, and we put the X. And this is for when we hear the words, I'm putting next to it, exactly. You might want to put that in your notes, right? When is it good to use this button? When you're hearing this binomial, in a binomial experiment, we hear this phrase, blah, 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 exactly. We look for keywords. What's the probability it makes exactly 35 out of 40? Autumn.
What if it doesn't say exactly?
I love it! That's coming up in the next question. Because here comes, there's a few others. Let me give you a heads up what's coming up, Autumn. They go, fewer than. Then they go, at least. And then my favorite, between. So don't worry, we'll go through it. We'll understand it. I'll show you a long way to compute it. Then we'll talk about, is there a quicker way?
Is that going to be on the test?
Oh yeah.
Right.
Oh, you'll crush it. You'll crush it. Hey, I'm going to do this right now. When you're telling me, just go, binom, PDF. This is the big number. Which one was it?
40.
All right, 40. This is success rate. Doesn't have to be 50%, right, Liz? In this case, it was
0.8.
0.8. And then,
35.
all right, what do we get? 0.0854. So I'll just go 0.085. So I want about 9% chance?
Mm-hmm.
If you want to, man, that's kind of low. Well, maybe this person's going to make 34 of them, or 33 of them, or 32 of them, or 31 of them, right? Good deal. Autumn, okay with that? All right. Hey, letter E. Can I erase the top part so I can get up to the top? E? Yeah? All right. That's the final experiment. Letter D, here comes letter E. What is probability. Still 40 attempts, so I'm on letter E. And he makes fewer. Fewer than 35
So should that be like a
baskets.
complement rule?
Yeah. So far, so good, everyone? Did everyone get the bottom? Can I raise the bottom? So this bipolar, that was exactly what? This. And when this looks like it's going to take forever to do this one. Fewer than 35? Can we put that in our own words? Oh my gosh, it looks like we're going to be hitting this button forever. Because that's this is the only button we know right now, right? That's going to take forever. Because I'll have to hit that for fewer than 35 means they can make, listen, I'll start 0 baskets, or 1, or 2, or 3, or 4, or 5, or 6, or, oh my gosh, and all the way up to what?
34.
Up to 34. I'm not going to include 35 because of the wording here on them. They didn't say like less than or equal to. They just said fewer than. That means 34 or lower. Well, if I do that the long way, I guess I could, but I'm going to have to hit this button, what? It's about 35 times. The 0 plus the 1 plus the, and write them all down and keep all these digits of accuracy and store all this. There's got to be another button for this, right? There's a button for cumulative. Everyone, you know what I mean by cumulative? Have you ever heard like students come up to me and go, Professor Mester, can you tell me my cumulative grade in this course? What are they talking about, cumulative?
All the grades.
All the grades up to that point, right? What's their actual average at that moment, including all their tests and quizzes and all that stuff, right? Well, there's a button for binomial where it will add up all these probabilities, starting from 0 up to this amount. So go back to that menu, look for something near binomial PDF. So this would be, look, 0 plus a 1 plus a 2 plus a 3 plus a 4, all the way up to, I'd have to add all these up to what?
34.
34. Liz, that would take forever, do you agree? So we use this button called a binomial. C for, guess what C stands for? Cumulative. It's going to sum all those probabilities of 0, or making it 1, or making it 2 baskets, or making 3 baskets. And you get to put the N, and then you get to put the P, and then you get to put the X. Now, I have to be careful here. So, 40 trials, right everyone?
Mm-hmm.
This is, for your notes, will you be very careful? I want to highlight this. I'm not putting a 35 here, am I?
34.
Did everyone hear? You said fewer than 35 means 0 through.
34.
So maybe for your notes, you might write here on and say, I always put x minus 1 here for fewer than. You might add that to your notes because I have to think, well, fewer than this would be 1 less than that. This will sum all of these. This is a powerful button. Do you agree? It's doing a lot of math for us. This kind of mathematics, in terms of technology, wasn't available years ago. And so we had to estimate this stuff. Because you're like, oh, that would take forever by hand. Well, now we have technology. I'm like, thank you. You facilitate. We just want to make sure, what are we trying to compute? We're trying to sum all these. We know how to do it the long way. Do you agree? Maybe add this and put a 0 and then a 1 and then a 2 and then a 3, right? So I'm going to do this. Now, that's a C for cumulative, binomial cumulative distribution. Oh, that was just the probability distribution for 1, right? Exactly. This is adding them all up. What do y'all get?
0.839.
0.839. Everyone get this? Awesome. What was after the 9?
It's actually 0.8386. I made it to 0.8.
Oh, okay. So 0.8386. They went to 3 decimal. 0.839. Roughly, you can just 84% chance, right? It's not 100% chance, though, is it? Hey, when I want to show you something on the calculator, all I ask you, when you see this, some students go, ooh, cool. But I'm going to give you, like, be careful about something, all right? Let me go in here. Let me hit the lights. And I'll tell you how to do it, because I know you got the new model. All right. Go over to y equals. Hey, I got stuff in here. We'll clear that out. Clear it out. Hey, my plots are highlighted. Go up to the plot and unhighlight them. Go into this. And then, see the y equals? Don't worry, we're not graphing a curve. But in this y equals, I want you to hit the binomial PDF. Not CDF, the binomial PDF. So go to second distribution. And where is it? I up arrow, by the way. I get there quicker. I hit the up arrow. And I want the PDF, okay? I'm going to hit this. So far, so good. Now with yours, what you're going to have to do is go all the way down to paste and have it pasted in there. But I'm going to have you list those numbers first before you do it, okay? So what I'm going to have you do, because I know you're not on the screen yet, it was 40, comma, 0.8, comma, so when you're on that screen, you'll go to that, I'll come back and help you. You got to put it in the vertical manner. And after this 0.8, I want you to hit the variable x. Now trust me, you don't have to do this during a test. Autumn, you don't have to, but I wanted to introduce this to you. I know. But what's weird is, what did I put here?
X.
A variable. So what I'm going to do is, I'm not going to look at the graph. I'm going to go over to the table button, and I want to see all these probabilities listed. I want you to see what you just computed. All right? So I am now going to hit table. To hit table, you got to hit second graph. You have to hit second graph. You don't have to do this. But what is just showing me, I'll do table set. I'll start at 0 and just go by ones. Let me know if anybody needs me to set their table. I hit what's called table set, which is second window. I'm going to make it go by one so it's